All right, this is the Algebra 2, Unit 7, Lesson 8 video over inverses of radical equations. You've already worked with inverses in previous units, and the way you do this with radicals is not going to be any different. So we're going to start off with how to do it algebraically. So what I mean by that is when we do the algebraic solution for an inverse, if you'll remember, I'll give a basic linear function example. We would take the x and the y and we'd switch them and we get a new equation. And then in order to find the inverse from that, we then solve for y again. And so we would just do basic algebra. And then we'd solve by dividing by 3. And we'd get y equals x minus 2 over 3. And so that was the kind of thing we did in the previous units. With exponential or rather radical functions, not much is different. You're still going to be doing the opposite. So for instance, if I was given something as simple as this, again, I switch the x and the y, and that gives me x equals y to the 1/3 power. I'm actually going to grab that, move it down here. So if I have x equals 1/3 power, I need to get rid of the 1/3 because I need y to be by itself. In order to do that, I'm going to take this, both sides of the equation, I'm going to raise it to the reciprocal power. So we know that 1/3 to the third is going to cancel out those 3's, leaving me with y equals, and then I'll have x to the third. And that would be the solution to that. So we'll call that number 1. Now for number 2, let's try one that's a little more complicated. Y equals x to the 1/4 plus 3. So again, I'm switching the x and the y. I get x equals y to the 1/4 plus 3. Again, just using algebra to solve this equation for y. So we'll start by subtracting 3. X minus 3 equals y to the 1/4 power. Now I have to do what I just said on the previous problem, which is I need to raise both sides of the equation to the reciprocal power. The reciprocal of 1/4 is 4. Those are going to cancel, giving me y equals x minus 3 raised to the 4th power. So you can kind of see how these end up. You're usually going to end up with some kind of power that's the opposite or reciprocal of the power you started with. Let's go look at number 3 down here. Say I have the following. Y equals, parentheses, x minus 2 to the 1/3 power. Switching the x and the y gives us x equals y minus 2 to the 1/3 power. And this one ends up being a little bit different because we can't get this 2 out of here until I get rid of this exponent. So I'm actually going to raise this entire thing to 3 on both sides so that those cancel out. This gives me x third over here equals y minus 2. And then I add 2 to both sides. X to the third plus 2 equals y. So that's the algebraic solutions, and that's going to be what you do in the first few questions here, 1, 2, and 3. I'm not going to say much about number 4. We know that when we look at the inverse of something, we're really switching the x and the y value. So when you see these problems here where it says name the coordinates, you need to take the original coordinate from the function and switch the x and the y values, and that's the answer that you get over here. So all you have to do is switch these coordinates from x to y and switch them so that the y value in the first one is now the x value in the second one, and the x value here is now the y value over here. So just switch the x and the y. That's number 4 and number 5. Then number 6 and 7, asking you about inverses in terms of the graph. And I'll just remind you, all you have to know about inverses when it comes to the graph is that if you have a coordinate plane and you have two functions. If they are symmetrical along this line, the line y equals x, then they are inverses. So it would look something like this. If this was like one function, the other function would need to look like that so that they were symmetrical. So you need to go look and see if the two lines graphed are symmetrical. So it says, does it appear that they're inverses? Why or why not? So you need to say yes or no based on what I just told you. And then remember, it's the line y equals x. So this blue line here is the line y equals x. So that is the line that determines if they're inverses. All right, that gets you through there, and the rest of this is going to be a review. So, actually, number 11 as well is another inverse question. So again, is it symmetrical? And they've actually drawn the line for you. So you just decide whether or not they're inverses based on the graph. And that's it for lesson 8.